This video is brought to you by Altium. Before we are going to write our first LED blinking program, there are a few things that I would like to explain so that you can easily understand the basic things. I explained the pinout of this ESP32 module in which the onboard LED is connected with the GPIO2. While in this version of the ESP32 Wi-Fi plus Bluetooth module, the onboard LED is connected with the GPIO5. You can see 5 written with this LED. For the LED blinking program, you don't need all these components. As a beginner, you can simply start with the ESP32 alone and start controlling the onboard LED, or you can simply connect an external LED with any GPIO pin of your choice. Now let's go ahead and take a look at the LED blinking code. For this example, we don't need any libraries as we are not using Bluetooth and Wi-Fi connection. I simply started off by defining a pin to which the onboard LED is connected. If you are using any other version of the ESP32 module which has the onboard LED connected to some other GPIO pin, then go ahead and change this number. Inside the white setup function, I set the GPIO5 as the output using the pin mode function. Using the digital write function, you can turn on and turn off any GPIO pin. By default, I want to keep the LED in off state. The code which is placed inside the white setup function executes only one time when you start the controller. The code which is placed inside the white loop function executes again and again until you turn off the controller. This line of code turns on the LED and then there is a delay of 1 second. 1000 milliseconds equals to 1 second. This line of code turns off the LED and again there is a delay of 1 second. So that's all about the programming. Now to upload this code, connect the ESP32 module with the laptop. As you can see, the onboard LED is off as the program is not yet uploaded. One more thing, if you don't know with which communication port your ESP32 module is connected, then you should open the device manager. Before you are going to upload the program, first of all, make sure you select the correct communication port and the correct version of the ESP32 Wi-Fi plus Bluetooth module, which is the ESP32 Diff module. Click on the Verify button to check for any errors. As you can see, the code has no errors, and now we can click on the upload button. You can see the LED is blinking. Now let's say you are using a version of the ESP32 module which has no onboard LED, or you want to use any other GPIO pin. Let's take a look at the circuit diagram and explain how to connect an LED with other GPIO pin. The anode side of the LED is connected with the GPIO 13 of the ESP32 module, and the cathode side of the LED is connected with the ground through this 330 ohm current limiting resistor. The anode side, which is the positive leg of the LED, is connected with the GPIO 13. A 330 ohm resistor is connected in series with this 2.5 volt LED. This is a current limiting resistor. The other end of the resistor is connected with the ground pin of the ESP32 module. So that's all about the interfacing. This is the same exact code which I just explained. I did only one change, that is I changed this number from 5 to 13, as this time I'm using the GPIO 13. Connect ESP32 with the laptop and click on the upload button and wait for a while. As you can see, the code has been uploaded, and now you can see the LED connected with the GPIO 13 is blinking. With this setup, if I need to run this LED for 2 hours, then the laptop should remain connected with the ESP32 module, which seems quite impractical. We can make our own regulated 5-volt power supply to power up the ESP32 Wi-Fi plus Bluetooth module. Let's take a look at the circuit diagram. This video is sponsored by Altium. Altium Designer is the world's most trusted PCB design system. Altium Designer enables engineers to effortlessly connect with every facet of the electronics design process. Over 35 years of innovation and development focused on a truly unified design environment makes it the most widely used PCB design solution. With Altium Designer, you can create PCB designs with an intuitive and powerful interface that connects you to every aspect of the electronics design process. Route it your way through any angle, tune for delay, push, slide, and walk around faster than ever. Interact and collaborate with mechanical designers like never before in a photorealistic 3D design environment. If you want to get started with the Altium Designer, you can click on the first link in the description. J1 is the DC female power jack, and this is where we connect our 9 volt to 25 volt DC power supply to power up the ESP32 module. While using a power supply, make sure you never exceed the maximum input voltage rating of the 7805 voltage regulator. Recommended power supply is 12 volts. 470 microfarad 16 volt capacitors are connected on the input and output sides of the 5 volt regulator. These are decoupling capacitors and must be connected, otherwise the ESP32 module will keep resetting automatically. The regulated 5 volts can then be connected with the ESP32 5 volt pin, and don't forget to connect the ground of the power supply with the ground pin of the ESP32 Wi-Fi plus Bluetooth module. I designed this ESP32 based development board and Gatesoft Eagle schematic and PCB designing software. I will add a link in the video description to download the Gerber files. It took around 15 to 20 minutes to complete the soldering. On the PCB board, you can see I have these two decoupling capacitors, 7805 voltage regulator, and this DC female power jack. All these other components are used to control the relays, which I will explain later in this video. Anyhow, now let's control the same LED, but this time we are going to power up the ESP32 module using a 12-volt power supply. You can see the LED is blinking, and now I'm not using my laptop anymore. So far I have explained the maximum basic things, and now you know exactly how to install the ESP32 board, how to write your first program to control an LED, and how to power up the ESP32 Wi-Fi plus Bluetooth module using a 12-volt power supply. Now let's go ahead and control the same LED using the BLYNK application. This time we will connect the ESP32 Wi-Fi plus Bluetooth module with the Wi-Fi. This way we will be able to control this LED from anywhere around the world using the BLYNK application. Before you can start controlling different types of electrical loads or monitoring different types of sensors, first you will need to download the BLYNK library. Just like the Arduino boards, the ESP32 Wi-Fi plus Bluetooth module can also be programmed using the Arduino IDE. You can download the latest version of the Arduino IDE from the Arduino official website. To download the Arduino IDE, click on the Windows zip file. If you want, you can support the Arduino development team with a small donation, or you can click on the Just Download button. This may take several minutes depending on the speed of your internet connection. Open the Arduino IDE. Go to the Tools menu and then to the board. When you run the Arduino IDE for the first time, you won't see the ESP32 board. You will have to manually install the ESP32 Wi-Fi plus Bluetooth module in order to be able to program it using the Arduino IDE. To install the ESP32 board, you will need this URL link, which I will add in the video description. Click on the File menu and then click on the Preferences and paste the URL link. And also check the compilation and upload boxes, and then finally you can click on the OK button. Again, go to the Tools menu and then to the board, and this time click on the Boards Manager and wait for a few seconds. Search for the ESP32. Select the latest version and then click on the Install button. This may take several minutes depending on the speed of your internet connection. You can see the ESP32 board installation is completed. Now let's go ahead and check if the ESP32 board is really installed. Great, we have just installed our ESP32 Wi-Fi plus Bluetooth module. While your Arduino IDE is opened, click on the Sketch menu and then go to the Include a Library and click on the Manage Libraries. Search for the BLYNK. Select the latest version and then finally click on the Install button and wait for a while. Our BLYNK library has been installed. Next, we will need to download the BLYNK application from the Play Store. The BLYNK application can run on both the Android and iOS supported cell phones. It's a good designing practice to first start with the BLYNK application. This way you know exactly which digital and virtual pins you will need for your project after you have downloaded and installed your BLYNK application. Open the BLYNK application. Click on the new project. Write the project name. Click on the Choose Device and select ESP32 This board and make sure the connection type is set to Wi-Fi and then finally click on the Create button. Authentication token will be sent on your registered email ID, which will be later used in the programming. Click anywhere on the screen to add a button. Write the button name. Next, click on the pin and while the digital is selected, search for the GP13 as our LED is connected with the GPIO 13. Our application is ready and now let's take a look at the programming. You will need to add this header file if you want to control ESP32 using the BLYNK application. This is the authentication token which was sent through email while making the BLYNK application. I simply copied and pasted over here. This is the name of the Wi-Fi router and this is the password. Next, I defined a pin to which the LED is connected. Inside the void setup function, I activated the serial communication using the serial.begin function, and inside the parentheses you can see 9600. This is the baud rate. I activated the serial communication only for the debugging purposes. Next, I activated the BLYNK and set the LED as the output. Inside the void loop function, we have only one function, which is the BLYNK.run function. So that's all about the programming. I have already uploaded this program. Let's watch this basic LED control system in action using ESP32 and BLYNK application. There is no change on the hardware side. The LED is still connected with GPIO 13. So let's go ahead and power up the ESP32 board. Now open the BLYNK application. Click on the play button and start controlling the LED from anywhere around the world. This is simply amazing. Now you can replace this LED with a relay to control AC or DC loads. This is what I'm going to explain next. But first, let's take a look at the circuit diagram. The power supply remains exactly the same. I have removed the LED. You can see 4 relays are connected with the ESP32 GPIOs 13, 12, 14 and 27. If you want, you can add more relays. All these relays are of the type SPDT, single pole and double throw. You can use a ready-made relay module, or you can make your own relay module by following these connections. You cannot directly control these relays using the ESP32 module. You will need a driver to turn on and turn off these relays. You can see I'm using a pair of 2N2222 NPN transistor and a 10 kilo ohm resistor to control each relay. So the 2N2222 NPN transistor and the 10 kilo ohm resistor make the driver circuit. One side of the relay coil is connected with the 12 volts, while the other side of the relay coil is connected with the collector of the 2N2222 NPN transistor, and the base is connected with the GPIO pin through this 10 kilo ohm resistor. You can connect your AC or DC load with the common and normally open pins of the relay. You can see this relay is connected with the GPIO 13, and if you remember, we have been using this pin to control the LED. This means we can use the same program and the same BLYNK application to control this relay. I will add a link to the PCB Gerber files if in case you want to make the same ESP32 development board. For the demonstration purposes, I have connected this 220 volt AC fan, which we are going to control wirelessly using our cell phone. Be very careful while working with 220 volt AC, as it can be really dangerous. Don't forget to wear protective gloves. So now you have got the idea how different types of loads can be controlled over long distance using Wi-Fi.